Well, hello. So today what we're going to do is we're going to move on to a different type of function. So we're going to talk a little bit about exponential functions. Now, in order to talk about exponential functions, we're going to have to remember or review a few things about exponents. Remember that when you have some a to the x, that a is the base of the exponent, and the x is the exponent itself, right? And it simply means to take a times itself over and over and over again. So for example, if we have 2 to the third power, that literally means 2 times itself 3 times. 2 times 2 is 4, times the third 2 gives you 8, right? Not 6. Don't ever multiply the base times the exponent. There's never a time when that's okay. All right? Now you have to be careful about what the base is, because if you have a sign, it's not part of the base in most cases. So here, the negative is just going to come down. 5 to the second power is 25. Okay? So our completed answer is negative 25. However, if the base is in a parentheses, then that means to take the entire parentheses and multiply it times itself, which is going to give you a positive 25 when you multiply those two together. So be really, really careful when you're doing these, either if you're entering them in the calculator or if you're doing them on paper. Make sure you're very careful to enter this properly and think about what the base is. The base is always the thing that the exponent touches. So here, the base is the entire parentheses. Here, the exponent of 2 is only touching the 5, so that's the only part that's included. Now, more to the point for this lesson, hopefully that's not something that's brand new to you, but more to the point for this lesson are some of the rules for how different exponents behave. Okay? So we're going to look at a few of them. And I'm going to just use a to stand for any number, okay? And then we'll use different, I'll show you some different exponents, but then I'll also demonstrate it with some numbers. The first and most basic one is if you have any number raised to the first power, that simply means itself. So, for example, 3 to the first power is the same thing as saying just plain old 3. So what that tells you is that every number has an exponent, even if you don't see one. Okay? If you don't see an exponent, you always assume that that exponent is a 1. An oddball is what happens when 0 is an exponent. And we get to some graphing, you're going to want to use that, so make sure you understand this one. Anytime you have something to the 0 power, that always equals 1. No matter what it is, anything to the 0 power equals 1. Okay? So, for example, let's say we have 5 raised to the 0 power. Doesn't matter that it started out being a 5. Anything raised to the 0 power is always going to equal 1. Okay? Another one, it's a little odd, is if you have a fraction. You know what, let's do negative first. Sorry about that. Let's say you have a negative exponent. So a to the negative 1. Doesn't really matter what the fraction is, or what the number is. It behaves the same. Remember from the last time we said that when we had reciprocal functions, then we put that as the negative. So that's all this is doing. It's all it's going to do is turn the fraction over. It's that negative is telling you that your base is in the wrong place. And this one doesn't look like a fraction, but it really is, because remember, if something isn't a fraction, that means it is a fraction. It's just over 1, so you don't bother writing it. So what's going to happen is this thing is simply going to move to the bottom where it belongs. Okay? So the a to the first is going to move to the bottom, and that leaves the coefficient of 1 in the top. Now, be very careful. It does not mean to flip it over. Okay, so make sure you're careful about that looks like what's happening, but it's not. This 1 in the top came from because there was a 1 in the front, all right? And in the bottom it was 1a, which is just plain old a. So say we have 3 to the negative 1 power. That negative is telling you that that 3, the base of 3, is in the wrong spot. It's in the top now. It should really be in the bottom. And even though if you don't have anything left there, you're going to put a 1, because even though you can't see it, there is a multiplier of 1, or a coefficient of 1 in front of that 3. So 1/3. If you just cannot do it any other way but thinking about flipping it over, you'll get it right most of the time, but that's a terrible habit, so be careful. Some of the shortcuts that we as math teachers teach you don't work always, and so they shouldn't be taught, period. Now, let's look at what happens when we have an entire fraction in parentheses. Now, if that parentheses wasn't there, this would not apply. Okay? But remember, the base of the exponent in this case is the entire parentheses. So what's going to happen is the a is going to travel to the bottom, the b is going to stay in the top, is going to travel to the top, I'm sorry. And when that happens, this exponent of 1 becomes positive because you've performed the operation. So say we have, for example, 3/4 raised, and I'm not going to use 1 here, I'm going to use -2 just for kicks. All right, so that means the 3 is going to move to the bottom, the 4 is going to move to the top, and it's no longer raised to the -2 power, it's raised to the +2 power. So you can see, and you can do that backwards too. So if I wanted a fraction, and you're going to see in the lesson where this happens, if I wanted a fraction with the 3 was in the top and the 4 was in the bottom, all I have to do is raise it to a negative power, and that will invert those numbers, right? Okay, so keep that in mind. You're going to see that later as we go. Okay, so we did just a positive integer, 0, negative integer. Now we want to talk about fractions. Let's say we have some a raised to the 1/2 power. Anything raised to the 1/2 power is the same as saying the square root of that base. Okay, so say we have 16 to the 1/2 power. That's the same thing as saying the square root of 16, which of course is 4. All right? Now, you can also have different fractions. A to the 1/3 simply means the third root of that number. So if we have 8 to the 1/3 power, that's simply the third root of 8. And 8 is 3 2's multiplied together, so just plain 2. Okay? Now you can have a different numerator. The top number of the fraction does not have to be 1. And so when that's the case, two things are happening. Okay, so we have a to the 2/3. The numerator is the actual exponent. The denominator tells you that you're taking a root. So we have both things going on here. So this is really the same as the third root of a raised to the 2nd power. And you have a couple of choices here. You could go ahead and work out a to the 2nd power and then take the third root of it, or you can use the laws of exponents, which say that you simply divide the exponent by the power. And I'll show you both ways. I think it's a little easier if you would just use the exponent rule instead of multiplying it out and then trying to take it apart again. So I'm going to show you that way when we get into the actual problems. So let's look, for example, at, I don't care. Say we have (16) to the 3/2. Okay? Now, that's the square root of 16 raised to the third power. Now notice that I put the third power inside the radical, but you don't have to. There's another way of writing it. It's the same as the square root of 16, that answer raised to the third power. Now this time, this form is much easier to use because the square root of 16 is just 4, then you can raise that to the third power. Now sometimes this one is the easier form to use because you're not going to have a number that's a perfect square there. If that's a perfect square, then the second form is best. But if it's not, then the first one works. And again, you're going to see some examples of that. And of course you do 4 to the third power, which I hope is 64. Yeah, that's it. Now, so we've talked about different ways, different things that can happen to you with exponents. And I think that that's all of the laws of exponents that you're going to experience in this particular section. It's really important to keep them in mind, not only because you're going to use them a lot, but because it'll give you an idea of what's going to happen to you later when we're solving some of these things as functions, solving some of these equations. Okay? So we have our laws of exponents, so let's look at a couple of exponents in our homework and see how to evaluate them. So the first things that they're going to have you do is simply evaluate an exponent for a particular a base for a particular exponent. So here we have if f of x is 5 to the raised to the x, find f of 4. So that's f of 4. All I'm doing is simply replacing the x with the number they told me to use, which is 4. So that means 5 to the 4th power literally means 5 times itself 4 times. So that's 25 times another 25. Okay. And multiplying those two together, you're going to get 625. Okay, so just multiply them together. And I usually multiply them out in pieces, but you could have just as easily said 5 times 5 times 5 times 5. Perfectly fine. Or, of course, your calculator can do exponents when it's just a plain number like that. Not a problem at all. It can actually do any exponent. So you could just put in 5 to the 4th power. And again, you all have different calculators. I don't know what kind of calculator you have, so you have to know the way your calculator works if you want to use the calculator to evaluate exponents. But be sure to write out that part so that you know what it is you're doing. Be really careful about it, okay? All right, here we go. So we'll just type that in. 5 to the 4th power gave us 625. And check your answer. All right. Now, the next one, we have a case where we're going to have to be careful about the exponent because it's not, the exponent this time is not going to be a positive 5, it's going to be a negative 5. So we're going to think about what that negative is going to do. So it's f of negative 5 equals 5 and to the x power, so that negative 5 is going to go up there. The first thing is we can't do anything until we take care of that negative, or you don't want to. It's easier if you don't. So if you take care of that negative, what that means is that the 5 and its exponent are simply going to drop to the bottom of the fraction, right? Remember, and then it becomes a positive 5, and now we can evaluate it. So that'll be 1 over 3,125. Okay, so that's 5 to the negative 5. Okay, we have a couple things we need to take care of here. Remember, we have an exponent, but that exponent is negative. So what's going to happen is, if we take care of that negative part first, it's going to put the 5 to the 5th power in the bottom of the fraction. Right? It just moves it across the denominator, across the fraction bar. Which means that I can now evaluate the exponent of 5 to the 5th, which is going to give me 1 over 3,125. 125. Okay, and go ahead and type that in just to be sure. So we need a fraction. It's 1 over 3,125. And there you go. Okay, so sometimes you're going to have two things to do. In this case we did because that was a negative exponent. Let's look at the next one. So the next one, make that bigger for you. Okay. So now we have, sorry about that delay, we have g of x equals 1/3 to the x, and we want to find g of 2. So, this is one I didn't show you in the laws of exponents, so I'll show you right now. Anytime you have something in parentheses raised to a power, in this case to the second power, that means you're going to raise everything inside to the second power, right? The parentheses means raise everything, and I kind of showed you that with the negative 2 to the second power. That means you include the negative and the 2 when you do the actual multiplication. So this is kind of the same thing. You have a fraction raised to a power. That's the same as raising the and it's in parentheses. Make sure that means raise the top and the bottom to the same power. So 1 squared, 1 to any power is of course 1, and 3 squared is 9. So your completed answer, 1/9. Now, let's type that in. There you go. Okay. To the next one. All right. This time we have a fraction as an exponent. So remember, a fraction as an exponent really means that you have a radical, a root. Okay. So for finding f of 3/2 equals 2, and that's raised to the 3/2 power. So the 3/2 power really means you're taking the square root. Can't draw a radical now. What the heck is wrong with me? Okay, let's try that again. The square root of 2 raised to the 3rd power. Now this is a small number, so it's pretty easy to go ahead and do the 2 to the 3rd power, which is 8, and then take the square root of 8. If you'll remember, that's 4 times 2, and you take the square root of 4, which is 2, and then the 2 comes out. But if you know anything about exponents and taking the roots of exponents, there's another way of doing that. When it's in exponential form, and of course these are going to be because that's where it came from, you can use a little bit of a shortcut of division. And you're kind of reminded about that because because the radical kind of looks like a division. Remember that the root here is 2. If you don't have a number there, you always assume it to be a 2. So just simply take, first, you're going to divide the exponent by the index. Now the index is whatever number there is there. This works anytime you have an exponent that you're taking a root of. Okay? And then the quotient becomes the exponent on the outside. The remainder remains, imagine that, under. That's the exponent on the inside. So let's look at this one using that process, because they are, again, exponents, so it makes perfect sense to use it. So f of 3/2 is 2 to the 3/2, just evaluating so that gives you the square root of 2 to the 3rd power. Now here's the exponent, right? And this is the index. So you'll just take 3 divided by 2. 2 goes into 3 one time with 1 left over. So that tells you that, and remember the base was a 2. This is the exponent on the outside. This becomes the exponent on the inside. Right? So 2 to the first is outside, and 2 to the first is inside. Remember, those are the exponents. Top one on the outside, bottom one on the inside. And of course 2 to the first is just the same thing as 2. So you can do the same thing. As long as everything is in exponential notation, you can use division, that division algorithm, to be able to get the answer without having to simplify the radical very much. Now, you may not like that. If you don't use it. But some of you will already know it, and others will find it much easier. Okay, there you go. 2 squared roots of 2 is your answer. All right, now this one is going to involve using your calculator, because there is no algorithm, there's no mathematical way to find an exponent that is a decimal. Okay, so unless that decimal turns out to be an exact fraction, and don't count on it, it's not going to happen. So anytime you have something raised to a decimal power, then you're simply going to have to use your calculator and plug that into your calculator and work it out. Now all the calculators are going to be different, and so you're going to have to follow the rules for your calculator when you're doing this. So get that instruction book, or go on YouTube and find a video. Everything has a video on YouTube for it, so you're bound to find your calculator brand and the directions for doing that. So we'll just do it on the calculator. So that's going to be 3 raised to the 2.34 power, and that's going to give you a big long decimal, and it says round to the nearest thousandth as needed, so it comes out as 13.07566,351 on my calculator. And thousandths, remember this is tens, this is hundreds, this is thousands, so we're going to take that 6 and use it to round up that 5. Remember, you just look to the number after the number you're rounding to, and thousandths is 3 decimal places. So this is going to be, because we're rounding, an estimate, right, approximately equal to 13.076. Not equal to, but of course they're going to put the little squiggly approximate or about in there for you. So that's 13.076. Let's put that in there and make sure I got it right. There you go. So if you have a decimal, then you're going to have to use the calculator. So if you're getting used to using the calculator to do your exponents anyway, then there you go. But do let me warn you that if you tried that with that fraction one that we did earlier, like 2 to the 1/2 power, it's going to give it to you as a decimal approximation, and that is not going to work. So you're going to have to do the right thing. Now 2 to the 1/2 power would be square root of 2, so that one would be pretty easy because there's nothing else to do to it. They want the radical, not the decimal, unless this blue part gives you the permission to use the decimal and round, then don't do it. Okay, so make sure you be careful about that. You might do it and then not understand why you're getting the wrong answer. Okay? Let's go to the next one and see what they do. Okay, now we're going to look at a couple of graphs, and these graphs are fairly easy because they behave in a particular, the function values of exponential graphs behave in a certain way, as long as you don't have anything really messy, and you're not going to in this particular case. And what you need to know is that if A remember a is your base, right? Some a to the x. If a is bigger than 1, then the graph does this. Okay? If a is bigger than 0 and less than 1, so in other words, a is a fraction, positive fraction, or decimal, then the graph is simply going to do the opposite of that. It's going to turn the other direction. Okay? And so most of the time you can identify what's going to happen. You don't have to plug in numbers or do anything about it because you can just look at the shape. So for example, here we have y to the 10x. Well, 10, that's this case, right? 10 is bigger than 1, isn't it? So that means the graph is going to go up. Well, the only one of these that does that is right there, right? You see, it just goes up. Now you could plug in some points if you wanted to and find the graph that fits. But if you can just recognize the shape, just like those parent graphs before, there's no reason to go through all that extra work. Now sometimes, let's go ahead and check that. Now sometimes you may have a graph where two of them look like they'll work, and so you do have to do a little mathematics. So if you look at this, look at our base here. The base, our a, is 1/2, right? The base of it, which means that it's going to be doing this business. Okay, but if you look at the choices they give you, there are two graphs that are doing that are starting up and going down. So I've got to decide which one is the right one. And the easiest way to do that, as long as they're both crossing that y-axis, the easiest way to do it is to choose x equals 0, because anything to the 0 power is always 1, right? So if you do that, it's y equals 1/2 raised to the 0 power, and anything raised to the 0 power is 1. So that gives you the point 0, 1. Okay? So if you start looking at your graphs here, we can simply choose the one that looks like it's going through 0, 1. So if you look at C, right, it's the right shape going down like that. Okay? But if you look at it, you see that right, it's going down. It's not drawing for some reason. There we go. But if you look at it, here's 0, 1, and that line is not going through 0, 1. Scroll over to the other one, however, there's 0, 1, and that line is definitely going through 0, 1. So your completed answer, your choice that you'll choose is D. Okay? So click on that. So we still knew to eliminate some of them because of the shape that we would get, but we had to do a little math to find the particular one we needed. Okay. Now here we're going to get into solving some equations. That's what we're going to do for the rest of these. So the last 5 of these, 6 of these are going to be solving the equations. And there are two ways you could approach this. If you know your laws of exponents, then you know what happens to these by exponents. And let's just go through that really quickly. Remember, if you use 0 as an exponent, it always turns the number into a 1. Okay? If you use 1 as an exponent, you always get the same thing you started with. If you use a negative exponent, that always creates a fraction, and vice versa. If you have a fraction and you turn it into a number that's not a fraction, that also means a negative exponent. And if you have a fractional exponent, that means a root. In other words, you make your base smaller, right? it always makes your base smaller once you take a root of it, because a root is always going to be smaller than the number that you get when you multiply that root out. Okay? And that's what's happening here. If you look at it, we have 9 to the x power, and that equals 3. So our base is a 9, but we're turning it into a 3. So we're making it smaller. So that tells us that our exponent has to be a fraction. And so you can just ask yourself, what root of 9 would be 3? The square root, so that's the 1/2 power. Now, so you can kind of do these intuitively as long as you know these laws of exponents. And I'm telling you, if you don't know these laws of exponents, at least these 4, then you're going to be in trouble later. But we're going to look at how you can do it mathematically. Because if you think about this for a second, it says that 9 to the x is equal to 3. Okay? So that means that these two things are identical. And we can use that fact to be able to solve this equation by making a new equation out of the exponents. But in order to do that, the first thing we have to do is we have to make sure that both sides have the same base. Now in this case, the base of that 9 is the base here is a 9, the base here is a 3. Remember, that's 3 to the first power, right? If it doesn't have an exponent, that would be an important thing to remember. And so go ahead and write in the exponents. So what I want to do is I want to see if I can change them to the same base, right? And it's always look at the smaller one and see if the smaller one is a root of the larger one. Okay? In other words, I can't change 3 to 3 times anything times itself, but 9 can be turned into 3 times 3. Yeah? So just look at the smaller one and see if you can use that as a new base. But remember, it has to be some number times itself, because we're talking about exponents here. So you couldn't use some number, like if it was 6, you couldn't use 3 times 2, right? It has to be the same base. If it's 6, then you're just going to have to use base 6. And this is called change of base, and it's a really important skill. So I really want you to make sure you're understanding what's happening. So we're going to turn the 9 into 3 times 3. Okay? Well, when we do that, we want it as an exponent. So 3 times 3, get rid of that line because I don't want you to think I'm working with a fraction here. 3 times 3 is 3 to the second power, right? So all I'm going to do is replace that 9 with 3 to the second power. Okay? So we want the same base. Then we'll rewrite using the exponents. Okay? So what we're going to do is we're going to replace that 9 with 3 to the second power. So this becomes 3 to the second power, still raised to the x power, don't forget the exponent that we already had, should equal 3 to the first power. Okay? Anytime you have an exponent on the inside and an exponent on the outside, that's the same as just taking those two things and multiplying them together, and that will give you one exponent instead of 2. Okay? So you'll multiply them together. So that becomes 3 to the 2x equals 3 to the 1. Right? All I did was multiply those two x's together. Then set the exponents equal to each other. And finally, solve. Now I know I've really used up a lot of space there, but we'll go through this entire problem again now that you have the steps. And these are always the steps. Get the same base, rewrite using the new exponents, set the exponents equal to each other, and then solve. So let's get a fresh page here and do this one again. So it's 9 to the x equals 3. Write them all with exponents. Write in all the exponents because you're going to need them in a minute. I can't turn a 3 into anything, but I can turn 9 into 3 times 3, right? Which is the same as saying 3 to the second power. So that becomes 3 to the second power, still raised to the x power, equals 3 to the first. Well, I don't want 3 to the second and the x power. Anytime you're raising a parentheses to a power, if you have two exponents like that, we can simply multiply them together. So that gives me 3 to the 2x equals 3 to the first. Now all I need to do is take these exponents, because you see the bases are the same, so who cares, right? They would divide away if you solve this. So just take those exponents and set them equal to each other, and then solve. To solve this one, the opposite of 2 times x is divide by both sides by 2, so I get x equals 1/2. So in other words, the exponent you would put on the 9 in place of this x, right? The exponent you would put right there to turn that 9 into a 3 is 1/2. Now again, most of you are saying, I already knew it was 1/2 because you take the square root of it, and that's what 1/2 power means. But you want to practice these when they're small. Remember, you didn't start out learning huge words to spell or to say. You started spelling cat, dog. So you want to start out small here so that you can practice the process. Okay? So let's type that in just to make sure that we have the correct answer. So it's 1/2. There we go. Now, the process is not going to change. Just finding the base might be a little bit more difficult, and remembering some of the processes of exponents to make sure that you can manipulate it so that the bases are the same. So let's look at this one. So we're going to solve the equation for the x. Notice that x is in the exponent, so this is an exponential equation, so we have to solve for that x. So what we're going to do is we want to first make sure our bases are the same. And 4 and 5 aren't going to get any smaller. You could turn 4 into 2 squared, but that's not going to do any good. So what we need to do is make the big numbers, see if we can turn these big numbers here into these numbers on this side. So 4/5 to the x power stays the same. Over here, now 125 can be written with a base of 5. It's 5 times 5 times 5, in other words, 5 to the 3rd power. 64 is 4 to the 3rd power. Right? And I got those numbers by looking over here at the first one and seeing if I could turn those numbers. I couldn't turn a 125 into something. Now, but what you notice here, though, is we're not quite ready because this 4 is in the top, this 4 is in the bottom. So these numbers are in exactly the wrong positions. They should be in opposite positions. Well, the way to fix that, okay, and remember, anytime you have a fraction raised to the same power, that's the same as saying that whole fraction raised to the 3rd. And if I want to flip them over, then all I need to do is not use the positive 3, but use a negative 3. Okay, so get rid of that. If I want to flip them over, and this becomes 4 to the 5th power raised not to the positive 3, but to the negative 3. Because remember, negative 3 will remove those things across the fraction bar. Now, I still have the 4/5 raised to the x power. Now, this one is the right base, 4/5, right? And it's raised to the negative 3rd power. Okay? So you may have to do a few manipulations in order to get this. Practice this because it's not difficult mathematically, but it requires some thought, right? And all I need to do to solve it is set the exponents equal to each other, and this time I don't even have to do any solving. The x is by itself, so x is equal to negative 3. So that's our exponent. That's our answer. What exponent would we use? We'd use negative 3. Okay? And I knew it had to be negative because I had to flip that fraction over, but so you still have to know a little bit about the laws of exponents. Okay, now this one's going to look worse, but it's really not. It doesn't matter what that exponent is. The process is the same. It just means that you have a bigger equation to solve in a minute. Okay, so we have 2 raised to the 2x minus 5 equals 16. Well, I've got to have the same base there and there. And I can't do anything to a 2. That's as small as it's going to get. But I can turn 16 into 2 times 2 times 2 times 2. Right? So always look at the smaller one and see if you can make the bigger one turn into some base with that. So that becomes 2 to the 2x minus 5 equals 2 to the 4th power. Okay? Now all I need to do is take the exponents and set them equal to each other. All we're interested in is the exponent part now. So that's 2x minus 5 equals 4. We'll add to 5 to both sides to get the 2x by itself. X times 2 is multiply, so the opposite of multiply is divide. So that divides out, gives us x equals 9 over 2. Okay? And that won't simplify because 9 won't divide evenly by 2, so we're just going to type it in as a fraction. Don't change it to a mixed number. Just type it as a fraction. So 9 over 2. And there's your completed answer. So once you have it as the same base, these are a piece of cake because we've solved so many other equations. Okay? Let's look at the next one. Now this time, they give you a weird base. It doesn't matter. It doesn't matter what the base is. As long as the base is the same, we can use this process. All right? So you may not know what E is. I don't care. It's E. It's just simply the base of the exponent in this case. Now we do want to simplify it a little bit because e to the 6 raised to the x power, we want to simplify that out a little bit. That's going to become e. Remember, if you have an exponent raised to an exponent, just multiply them together. So e to the 6x. All right? Now, what we'll do is set the exponents equal to each other, create an equation, and solve it. So 8x minus 1 equals 6x. Now we could move the minus 1 that way and then move the 6x, but if there's only one number term, I'm going to leave it alone. I'm going to instead move this positive 8x to be over here with the other x term. That gets rid of that, gives you negative 1. 6x's minus 8x's is negative 2x's. Now that's negative 2 times x, so we'll divide both sides by negative 2. Now, it has to be a negative 2 because I need that negative and that 2 to divide away. Well, negative 1 divided by 2 is just going to give me positive 1/2. Okay? So, solving the equations is going to be where most of the work is, but that shouldn't be that big of a deal to you since we've solved so many equations in the past. So we're going to get a fraction, and the fraction is 1 over 2. There you go. Okay, so the mathematics is really easy. The process is a little odd. Okay, let's look at this one because in this case, okay, we have 256 to the 3x equals 64 to the x plus 2. So our smallest base is 64, but if you take 64 times 64, you're going to get 4,096, which is way bigger than what we have here. So I can't use 64 as the base, the common base here. So what I'm going to have to do is I'm going to have to find some number that will work for each one of them. Okay? So most of you were probably thinking 64, well that's easy, that's 8 times 8, right? Okay, and so yeah, you're exactly right, that is 8 times 8. But you got a problem when you come over here, because if you multiply times another 8, you get 512, which is not what you're looking for. So we can't use 8 as a base. So what we try to do is try to find some other smaller base. Now you could use 2, but that would be really, really small. So what we're going to do is we'll try, if 8 didn't work, We know that 64 is also 4 times 4 times 4, just from using it over and over and again. Okay? You can just try some numbers. We know it has to be an even number because they're both even. But so 8 was obvious but didn't work. So go to the next even number. You could try 6. Well, 6 won't multiply times itself and give you a 64, but 4 will. Okay? So let's try 256 and see if that works. Okay? We already know that 64 is 4 times 4 times 4, and if you do multiply 4 times itself 4 times, that gives you your 256. Right? So sometimes you'll have to change both bases, and it's a bit of a process to determine what number to use. Now let's write them in exponential notation. That's 4 to the 4th power. Remember the exponent we already had, though, raised to the 3x, and 4 to the 3rd power raised to the x plus 2. Okay. Now we don't like exponents raised to exponents, but remember all we have to do is multiply them out. So here, 4 times 3x, that's easy. That's just 12x. But here, remember, we have 3 times x plus 2, so that's the distributive law property. We have to multiply that 3 not just times the x, but times both of them. So 3 times x is 3x. 3 times positive 2 is positive 6. Okay? Don't forget, it's times the entire x plus 2, not just times one of them. Now we have our equation, because I've just set the exponents equal to each other as I did the multiplication. So we'll get the x's on one side by themselves by subtracting the 3x. That gives us 9x equals 6. Then we'll divide both sides by 9 to get that 9 away from the x, which gives us x equals, now 6 won't divide evenly by 9, but they'll both divide by 3, so that's going to give you 2/3. Don't forget to reduce. If you have a fraction, you have to reduce it. Okay? So we ended up with, oops, sorry about that. Yeah, we're still recording. We ended up with 2/3. And there's your completed problem. Okay? Let's go look at the last one. We have 16 and 64. And again, what's going to happen here, 16 and 64, they're not the same base already. So 16 to the 3x equals 64 to the x plus 2. If you took 16 times 16, you're not going to get 64. So 64 is too big. But it's easy to see 16 as a 4 times 4, right? And 64, we know from experience, is 4 times itself 3 times. So this time we have a base of 4. That's not always going to be the case. You could have just as easily have bases of 5. Just depends on your numbers. So that becomes 4 to the 2nd raised to the 3x, and 4 to the 3rd raised to the x plus 2. We don't want to leave two exponents, so we're going to multiply those out. Here it's just 2 times 3x, which gives us 4. I'm sorry, we don't need the 4. Remember, we don't need the base. All we need is the exponent. So it's going to be 6x. Here it's 3 times x plus 2. So 3 times x is 3x. 3 times positive 2 is positive 6. Don't forget to use that distributive property so you can get the right answer. You're multiplying the 3 times both of them. We'll get all the x's on one side by subtracting our 3x's, which gives us 3x. These subtract away. So 3x equals 6. Then we'll get the x by itself by dividing both sides by 3, which gives us x equals 6 divided by 3, which of course is 2. Okay, now we'll just type that in. Check it. Oops. What did I just do? They use powers of 2. Why? Hold on a second. Okay, well, powers of 4 should work, but if you were paying any attention, you'll know where my mistake was. The exponent on the first one was 3x minus 3, and I just wrote it as 3x. So I wrote the problem down wrong. Imagine that. So we're going to do it again with 4s, just to show you that it won't matter, that exponent won't matter. 4 squared raised to the 3x minus 3, okay, there's where my problem was, equals 4 to the 3rd raised to the x plus 2. Now they went to an exponent of 2. You don't have to. I mean, a base of 2. You can just find any base that will work fine and produces out in the end. So that gives you 4. Multiplying these out gives you 6x minus 6. Multiplying these out gives you 4 to the 3x plus 6. Setting those exponents equal to each other, now that I have the actual correct exponents, gives you this. Add 6 to both sides to get the numbers on one side. Subtract the 3 from both sides to get the x's on the other side. And then lastly, divide by 3, which gives you x equals 4. Let me try that one. Writing the problem down wrong. Perennial mistake. There you go. So again, as long as you can get the same base, you don't have to go down to 2. Many times, if it's an even number, they'll go ahead and go down to 2 because they know it always works. But it also makes all your numbers much bigger. But, you know, it works. Okay. So that was number 13 of 13. And except for that last problem, I was generating along pretty good there. Hopefully that didn't mess you up too much. Remember these. Anything to the 0 power turns it into a 1. Anything to the first power is itself. Anything raised to a negative power will turn it into a fraction or will reverse the fraction. Anything to a fractional power is actually a root. And if you have an exponent inside and an exponent on the outside, those will be multiplied together. If you have a fraction raised to an exponent, that means the top and the bottom raised to that same exponent. Okay? So, if you don't know these rules, you're going to be into some trouble, so make sure you practice those. Thanks, and I'll see you next time when we start talking about logarithms. And don't let that freak you out. They're just exponents.